Okay, so for the first part of this lab, we're going to go ahead and set up all the solutions we're going to use throughout the entire procedure. We're going to start with our buffer, which has actually got a prescription for us here. To make our buffer, we need some 0.2 molar sodium acetate, about 100 mils of water in an Erlenmeyer that I've labeled for our buffer, and some 1 molar acetic acid. So I've gone ahead and already measured out the volumes we need here. We're going to take about 50 mils of the sodium acetate and add it over to our distilled water in our beaker, or our funnel. And then we're going to add about 10 mils of our acetic acid to the same flask. And then we're just going to swirl this around to get it nice and mixed up. And that's our buffer. With our buffer made, now we can start making our hydrochloric acid solution. So for this, we have a solution of 1 molar hydrochloric acid that we want to dilute into a 0.1 molar solution of hydrochloric acid. Work like this is probably one of the most important things you guys can really get a firm grasp on in these labs, because it's one of those skills that you'll use a lot if you ever find yourself working in a lab situation. So to do this dilution, we're going to use this equation for diluting solutions. You'll use this quite a bit if you ever have to do a lot of dilutions. So the equation is CIVI equals CFVF, where CI is the initial concentration of the acid or the solution we're working with, and V is the initial volume of that solution we want to use. CF is the final concentration we're going for, and VF is the final volume. So in our case, our initial concentration is 1 molar. We don't know what our initial volume needs to be, but we do know that our final concentration is going to be, we want that to be around 0.1 moles per liter. For the final volume, we're going to try to make 200 milliliters of this. So even though the lab procedure gives us the amounts that we need here, I wanted to go ahead and run through using this equation. So our situation is we want to prepare 200 milliliters of 0.1 molar hydrochloric acid from 1 molar hydrochloric acid. The first thing we'll do is use our dilution equation, and we'll figure out what values are what. So we're going to start at 1 molar. We're going to end at 0.1 molar, and our final volume is going to be 200 milliliters. So we need to figure out how much of that final volume has to be made up of the 1 molar hydrochloric acid. So we let the initial volume be x, and we'll arrange the equation, and we'll solve for x in this equation, and we find that x turns out to be 20 milliliters of 1 molar hydrochloric acid. So the last step, we need to figure out how much water then we have to add to the solution. So the final volume needs to be equal to the amount of acid and water that you're adding to the dilution here. So our final volume is going to be 200 milliliters. Our volume of hydrochloric acid is going to be 20 milliliters. We arrange the equation like this, where the volume of water is equal to the final volume minus the volume of hydrochloric acid. So 200 milliliters minus 20 milliliters, we need about 180 milliliters of water. So I've taken a 250 milliliter Erlenmeyer. I've labeled it with 0.1 molar HCl. I'm going to add about 180 milliliters of water that I've measured out. And remember, the general rule is add acid to water. So here's our hydrochloric acid, about 20 milliliters here. And then we'll swirl this around. To get that mixed up. Now we're going to do the same process to make 0.1 molar sodium hydroxide solution. We have to dilute down from a 1 molar solution of sodium hydroxide to get to this 0.1 molar sodium hydroxide. We're still looking to make 200 milliliters. So all the work we did in the last part, where we calculated diluting down from 0.1 hydrochloric acid from 1.0 molar hydrochloric acid, it's the same thing here. We have the same numerical values, so we're just going to repeat the same process. So I've got 180 milliliters of distilled water. To which I will add about 20 milliliters of 1 molar sodium hydroxide. Mix this up, swirling it around. And we're ready to begin looking at our buffers.